This lecture is about the liver. Now, the liver is an incredibly complex and important organ, and it is so complex in its functions that we actually have 3 different categories of functions for them. So I'm going to start on that now. So the liver is your largest visceral organ. That basically means the largest organ in your abdomen. And it is so big, so important, that it has 3 basic categories of functions. So I'm going to start then with the first category, which is then metabolic regulation. So here's what's going on with this. All of the blood leaving the absorptive areas of the digestive tract that is to say, blood that is full of nutrients and other absorbed materials that blood then, and this is the important part, passes through the liver before reaching general circulation. Okay, what did I just say? This is actually incredibly important. What's going on is this. You've heard probably in high school about how you have blood vessels that absorb the nutrients from your digestive system. It's why you have a digestive system, is so that you can actually then have those nutrients absorbed out of the gut and into the bloodstream. But the thing is, that blood is now incredibly unbalanced. It may have a lot of sugar. It may have a lot of a certain vitamin. There may be various things where it would not be good for most of your cells to receive blood in that condition. So what happens first is that the blood from the absorptive areas of your GI tract, that blood enters a special vein called the hepatic portal vein. We'll talk about that when we talk about the circulatory system. But the blood enters the hepatic portal vein from basically the blood vessels surrounding the small intestine and the large intestine. Those blood vessels put their blood into the hepatic portal vein, and the hepatic portal vein brings that blood to the liver. And then the liver works on that blood and adjusts it and makes it suitable for general circulation for your cells to receive. So that's what I'm going to talk about now, having to do with metabolic regulation done by the liver. Okay, so what happens then with metabolic regulation of the liver? That blood passing through the liver, then this allows the liver to do a whole bunch of things. First of all, monitor levels of metabolites and adjust them. And this then is done through a whole bunch of means. So this is done by removing and storing excesses. And correcting inadequacies by depleting stored reserves and by synthetic activity. What did I just say? What I just said is this. Okay, so there are going to be various things coming into your liver from the blood. The blood, as I said, may not be appropriate for your cells to receive. So what do? What we wind up doing then in the liver, what the liver does then is if there are things in the blood that are there in too great a quantity, it'll take them out. So it will actually remove and store things that are in the blood in excess quantities, in too great a level. But on the other hand, if your blood is lacking in something, then it will actually put that something into the blood, both because the liver has stored extra materials against needing them later, and the liver can actually create things. That's what synthetic activity is. That's basically making stuff. So as I said, the liver can both make things chemically and it can also take things out of storage in order to make sure that your blood has in it what it needs and does not have excesses of other things. So the liver is pretty amazing. Okay, so that then is matter A. That is still, we are still just talking about the first category of function. We just did the first subcategory of the first function. So carrying on, having to do now with metabolic regulation. Now we deal with toxins then in the blood and metabolic wastes then these are removed. So there are plenty of things in your blood that could be poison. Your liver takes out some of them. It also takes out some waste products. And then finally, and this still just has to do with metabolic regulation, we have vitamins. Vitamins A, D, E, and K, then, all of which are fat soluble, and I will get into that in just a moment. So vitamins A, D, E, and K, all of which are fat soluble, are absorbed and stored. And I'm just going to say briefly, vitamins B and C are water soluble. And can't be stored in the body. Okay, what did I just say? Okay, vitamins A, D, E, and K are fat soluble. What do I mean by that? You've learned about solubility in chemistry. Some things are water soluble, some things are fat soluble. Your body is an aqueous environment. It's a watery environment. So anything that can be dissolved in water is going to be flushed away. On the other hand, since it's an aqueous environment, things that can be stored in fat, things that are not dissolved in water, can be kept in your system. So the liver can store these vitamins, A, D, E, and K, against your needing them later. And this is why if someone is going to get a disease of a vitamin deficiency or a problem having to do with vitamin deficiency, it's more likely to be due to a deficiency of vitamins B or C. There are many B vitamins, but that is because they cannot be stored. So you have to be taking them in through your diet on a continuous basis. Whereas with these, if you took them in a reasonable level at another time and your body was able to store some of them in your liver against needing them later, you're less likely to wind up having a deficiency sometime later. I'm hoping that this is making sense. So that then all has to do with the metabolic regulation function of the liver. Now I'm going to move on. Okay, so the next category of function then is what is called hematologic regulation. So this now, heme tells you it has to do with blood. So this then has to do with your cardiovascular system. So what happens here is that the liver receives 25% of your cardiac output. And it also serves as the largest blood reservoir. So there's your liver, full of blood. So then, as blood passes through the liver, which you already know it does, then as the blood passes through the liver, you have phagocytic cells that remove aged or damaged red blood cells, debris, and pathogens. So what did I just say here? This is kind of amazing. Okay, so you have these phagocytic cells in your blood. Phagocytosis, I hope you remember it then, is when a cell engulfs another cell. I hope you remember this from when you were studying cells. Is you will have a phagocytic cell, like a Pac-Man, basically, and a phagocytic cell will actually engulf debris or pathogens, remember things that want to make you sick, or aged or damaged red blood cells. So we have these phagocytic cells. Phagocytosis, remember, is a process. There are many different kinds of cells that can do it. So we have these phagocytic cells that grab onto other materials and basically engulf them and digest them. That is how we get rid of aged or damaged red blood cells. Remember, your red blood cells do not have a nucleus. And so they are in the process of dying, basically, by the time they reach circulation in your blood. They last a few months. Then they have to be taken out of circulation because they're dead. So your liver is constantly then taking out red blood cells that have passed their use-by date and debris, which can exist in the blood, and also pathogens, things that want to make you sick. So the liver is doing all that by way of its phagocytic cells. Now we're still dealing with hematologic regulation here. So also, still having to do with helping your blood, then, your liver cells synthesize what are called plasma proteins for the blood. So plasma proteins, what are they? Plasma proteins, then, are proteins that circulate in your blood. They are what make up your blood plasma, or what make up a lot of your blood plasma. And so these plasma proteins have a number of different jobs. Okay, so these plasma proteins do a bunch of different things. So they determine what is called the osmotic concentration of blood. Okay, what's that? What is the osmotic concentration of blood? It goes like this. Basically, you need to have the same level of water. You need to have the same concentration of water outside your blood cells as inside your blood cells. This goes for your other kinds of cells as well, but we're talking about the blood. So here's what happens. You need to have the same level of blood. Pick a number, 75% water or 80% water or 90% water, whatever it is, you need to have the same amount of water inside your blood cells as outside your blood cells. If you don't, then water will either be drawn out of your blood cells or water will enter your blood cells and potentially make them burst. This is why you cannot store blood cells in pure water, because the water will just enter the cells because it's in higher concentration outside the cells than in, and you will wind up then just with your cells bursting. So, you know that inside the cells, you have various organelles, you have nutrients, you have proteins, you have all kinds of things there. And so you are going to have, as I said, only a certain concentration of water inside those blood cells. So then you need to balance it out on the outside, and it's going to have to be adjusted from time to time. So we have this whole class of proteins in our blood, this whole class of plasma proteins that exist entirely to make sure that the water concentration in your blood is the same as the water concentration in your blood cells, so that your blood cells neither lose nor gain water. So that then is the osmotic concentration of your blood. And as I said, we have a whole bunch of plasma proteins that exist entirely just to make sure that the ratio of water to other substances inside your blood is the same as the ratio of water to other substances within your blood cells. That's what osmotic concentration of blood is. So what else do these plasma proteins do? Well, they also, different ones then, transport proteins. They also establish the clotting system. There are some blood proteins that are intimately involved in helping your blood to clot. Again, we will get to that when we talk about the circulatory system. And there are also plasma proteins that take part in your immune response. So that then is all under category 2. Then we have, finally, category 3. The synthesis and excretion of bile. So yes, your liver makes bile. that may be the one and only thing you ever heard about it doing before. There we are, the synthesis and excretion of bile. So bile is this kind of weird combination substance. So bile then contains water, salts, no, actually, let's take that out. We'll talk about that some other time. Contains water, electrolytes, the odd waste product bilirubin, and lipids. Okay, so bile, as I said, in part is your liver taking bilirubin, which is a waste product, out of your blood and sticking it into the bile to get rid of it. It also contains water, which can help to reduce the concentration of various substances coming out of your stomach, and so on. So, the water and the electrolytes then dilute and buffer the acids in chyme. You remember chyme, this substance coming out of the stomach, highly acidic because you have all that stomach acid, hydrochloric acid, coming out of the stomach. So this then helps to dilute and buffer the chyme so that it's not so dangerous to your cells. And so this then happens then as the chyme enters the small intestine. So now, bilirubin is largely a waste product. So this is just your way of the liver taking the bilirubin and sticking it into your GI tract, because your GI tract will get rid of things. And then finally, the lipids are what are called bile salts. And these then are necessary for the digestion and absorption of fats. So the liver is this incredibly complex organ. The liver has over 200 functions. We could easily have a course on the liver alone and have plenty to say. The liver is divided into lobes, and the functional unit, the aspect of the liver basically that gets the job done, the functional unit then of the liver is the lobule. And in the lobule, then, cells called hepatocytes. So take a look at the word where you see hep. That has to do with the liver. And cyte, of course, means cells. Cytes means cells. So in the lobule, then, you have hepatocytes, liver cells. So then in the liver, your hepatocytes then cluster around a central vein, a tiny central vein. The arrangement looks a little bit like bone. So you will have the central, very tiny vein, and then around it, almost sort of daisy fashion, you will have cells clustering around. And many of these cells surrounding the blood here in the middle, this very slow-moving blood in this tiny little blood vessel. Many of these then will be hepatocytes. The arrangement is kind of like bone, as you recall, where there is a central vein and then you have cells surrounding it. And in this arrangement, you will also find your phagocytic, what are called Kupffer cells. Which are also located here. So, we'll have a couple of Kupffer cells here doing their phagocytosis. And then between the lobes of the liver, you find the gallbladder. And the gallbladder then is where that bile that was created by the liver, the gallbladder is where bile is both concentrated and stored. So the liver makes the bile, and some of that bile from the liver winds up going directly into the bloodstream. But then some of that bile winds up going into the gallbladder, where it is concentrated and then it is stored, and it will go into the bloodstream at a later time. And that's it for the liver.